Good morning, everybody. In this video, I'll talk about the differences between AC and DC. AC stands for the alternating current, while the DC stands for the direct current. What does the alternating current means? The alternating current means it is continuously changing or continuously fluctuating a direction, while the direct current or the DC means it remains constant. So I will give you an example here. First, the AC or the electricity comes in two forms. It can be AC or it can be DC. It can change its magnitude and direction, while the DC always remains constant. So let's take a look at the main differences between AC and DC. As I mentioned before, AC stands for the alternating current and the DC stands for the direct current. AC source provides the voltage or current that fluctuates or changes direction periodically, while the DC source provides a voltage or current that does not change with time. For example, here, if I look at the time versus voltage graph or the current graph, it remains constant. It does not change. Okay, there can be a small ripple, but it does remain constant. But while you look at the AC source, for example here, as the time passes by, it goes here positive, then goes negative, positive, negative. So it is continuously changing its direction. Even here, this kind of wave or this kind of source we call as a AC source with a sinusoidal voltage. Sinusoidal. Because the form is the sine curve here. And now if I look at another example, a square wave, here this one is a certain value, positive, then drops to negative, again goes to positive, negative. So it is continuously changing its cycle, and we call this kind of form as a square wave, a square AC source. Now this one is an example of triangular AC source. So here the voltage continuously changes, then decreases again. So here this range is positive, this is negative, again positive and negative. So its direction is continuously changing from positive to negative. Now let's draw a circuit here. So I have a resistor here connected to a DC source. Remember, the DC source is denoted by the two lines passed here. This is the positive terminal, that's the negative terminal. The bigger line or the longer line is the positive and the smaller line is the negative. So this is the symbol for the DC source. Okay, while the AC source is denoted by a circle and the sine wave. For example, this is the symbol for the AC source. And if I connect a resistor along with a DC source, the direction of the current is always from the positive to the negative terminal. You see the positive to the negative terminal, that's the direction of the current. But now if I connect a DC source across a resistor, the current direction fluctuates. For example, if I consider this point, at one point the direction of the current is this way, and at the other time the direction of the current will be this way. So the current goes this way, current goes this way. So the current fluctuates. So how come the current fluctuates? So first let's give you an example with a sine wave of the sinusoidal AC source. So when the source voltage is positive, between these 2 points the source voltage is positive, the current will be in one direction. And when the source voltage is negative, for example here, the current will be in the opposite direction. As the voltage continuously changes from positive to negative, so is the direction of the current. The current direction changes accordingly. If it is positive, it will be this way. If it is negative, it will be this way. Now, what are the sources of alternating current? So you might have seen the power outlet in your home, that is the AC source. The generator, the turbines are the source of AC power, while the DC source is the battery and the solar cells. Anything, I'm talking about the AC source, anything that is rotating continuously will always give you the AC power. So when something is rotating, then there is always associated with frequency. So AC source has a frequency, while the DC source has no frequency, or we call it zero frequency. Okay, the frequency of DC is 0 hertz because it does not fluctuate with the time. Okay, but as the AC is fluctuating as the time passes by, it does have a frequency. For example, in US, the frequency of the outlet voltage is 60 hertz. So what does this mean? In 1 second, it makes 60 complete cycles. So one cycle, for example, will be, this is a one complete cycle. Okay, that's the one complete cycle. And the voltage from power outlet in USA will change 60 times, or will make 60 complete cycles. That's we call the frequency. We'll talk about more. So now the other significant differences between AC and DC is AC can easily be transferred over a long distance. For example, AC can be transferred from California, if there is a power plant, to Texas. It can be transferred easily over a long distance, but DC cannot be transferred over a long distance because of the significant power loss. If you look at the wire, the electrical wire, it does have some inbuilt resistance, and there will be huge the power dissipation through the wire. So the DC cannot be transferred over a long distance, while the AC can. And the other very significant differences between AC and DC is the AC can easily be stepped up or stepped down. For example, now let's say if you have a AC source of 20 volt, then using a transformer, you can easily convert to 200 volt or even to 2000 volt, or you can convert it to 2 volt. So you see, it can be stepped up or stepped down. That is for the AC. But for example, if you have a battery that tells you 9 volt, you cannot step up, you cannot step down using a transformer. So the transformer works only for the AC voltage. It does not work for the DC, the voltage or the DC source. If you look at any DC circuit, the passive parameter is the resistance only, but it does have 3 passive parameters: R, L, and C. R stands for the resistance, L stands for the inductor, C stands for the capacitor. Resistor, inductor, and capacitor. So that's the passive parameter. The passive parameter simply means it consumes electricity or it dissipates energy. That's what we call the passive parameters. And the power factor that we'll talk later for the DC is always 1, and the power factor of the AC is always smaller than 1 and greater than 0. So it always lies between 0 and 1. Okay, so these are the main differences between AC and DC circuit. And in the next video, I'll talk about the frequency RMS voltages. So this is it for this video. If you have any questions, write down in the comment section below, and do not forget to like, share, and subscribe the channel. Thank you very much.